Make it zoom package that.
你可以说话了。
Hello?
Yes, Professor, we can hear you clearly.
I can hear you.
Okay, we will start within 5 minutes, right?
Sure. Finally, we can make it.
Yeah, we will start within 5 minutes. Thank you.
Yeah, we can start on time.
DMC
你现在可以转到网页可以转到这个这个。I will little bit start with the introduction of our cooperation between. Hello, everybody. Lucia, yeah, nice to meet you.
Yes, yes. Yeah. We can start actually. Good afternoon, everyone. Yeah, Professor, we will start now. Yeah. Good afternoon, everyone. On behalf of the Indian Ocean Rim Association, Center of Excellence of the Ocean Sciences and Environment, it's my great pleasure to welcome warmly you to our third webinar in this series. Today's webinar mainly focuses on moisture flux impact of the DITWAH tropical cyclone on rainfall and floods in Sri Lanka. And we are honored to have Professor Dongxiao with us, who will share his expertise and insights. We sincerely thank all participants, resource persons and partner institutions for joining us today. We look forward to an engaging and informative session. It's now my great pleasure to introduce our distinguished resource person for today's webinar, Professor Dongxiao. Dongxiao is a distinguished Chinese oceanographer and an internationally recognized expert in physical oceanography and ARC interactions. He currently serves as a professor and dean of the School of Marine Sciences at Yat-sen University. Professor Wan obtained his BA, MS and PhD degrees from the Ocean University of China, completing his doctoral studies in 1996. Over the past 3 decades, he has built an outstanding academic and research career, previously serving as a Vice Director of the South China Sea Institute of Oceanology and Director of the State Key Laboratory of Tropical Oceanography. He has over 15 years of professional engagement with Sri Lankan institutes. Throughout this time, he has built long-standing collaborations with several universities, research centers and government organizations. His continued partnerships have supported joint research projects, academic exchange, technical training and institutional development, significantly strengthening international cooperation and contributing to Sri Lanka's scientific and academic progress. His research focuses on ocean circulation, ARC interaction, ocean atmosphere coupling and multi-time scale variability, with particular emphasis on the South China Sea and the Indian Ocean. Professor Wan has led numerous major national and international research projects, including national key R&D programs and projects funded by the National Natural Science Foundation of China. An accomplished scholar, Professor Wan has published extensively in leading international journals such as Journal of Geophysical Research, Journal of Physical Oceanography, Climate Dynamics, and Nature Communications. His contributions have significantly advanced understanding of tropical ocean dynamics, mesoscale eddies, monsoon variability, and climate-ocean interactions. Beyond research, Professor Wan has played an active role in international scientific leadership. He has served on editorial boards of several prestigious journals and contributed to global scientific initiatives such as the World Climate Research Program and CLIVAR panels. With his extensive academic leadership, research excellence and international collaborations, Professor Dongxiao continues to make substantial contributions to the advancement of marine science and climate research worldwide. Without further delay, now it's my great pleasure to invite our distinguished resource person, Professor Dongxiao to deliver the webinar and guide us throughout today's session. Over to you, sir. Thank you.
Thank you. Thank you, Chairwoman. Thank you, my dear colleagues of Sri Lanka. It is my great honor to introduce, at the beginning, to introduce my history in cooperation with the Sri Lanka colleagues. Next. I'm so happy, Xia. I'm so happy in last more than 25 years, I have a very good cooperation with my Sri Lanka colleagues. Next. So this is a kind of a timeline. Next. I, at the very beginning, we have a official MOU with Ruhuna University. In last 2 decades, we have lots of activity. Next one. Now it's very fundamental for international cooperation between China and Sri Lanka for promote our understanding ocean and climate. Next one. This is what we done recently with the Sri Lanka University. Myself, stranger, and meetings. I visited many times of our Sri Lanka units. Next one. And also Sri Lanka colleague visit China many times. Particularly 2 years ago, we have an official MOU with Sri Lanka Ocean University and Sun Yat-sen University. Now we hand by hand have lots of activities. Next one.
Professor, could you please switch? Your mic is unmuted. Could you please unmute it?
Unmuted. Okay. 是不是没有说话？
打开了已经。
Now you can hear me? Can you hear me?
Yes.
Okay. CNEC is very important. I hope Sri Lanka Ocean University also can develop some cooperation with domestic units such as NARA, IUCN, Sri Lanka, and CNEC. Next one. Yeah, I continue my cooperation with Ruhuna University. I invited so many Chinese scientists to visit Ruhuna because Ruhuna University is the location of China-Sri Lanka Joint Center building. Next one. Yeah, we also invited lots of Chinese colleagues to incorporate with Sri Lanka colleagues. Next one. Yeah, we not just exchange, we also have a scientific cooperation output. Next one. First, we have a very good cooperation with Sri Lanka Navy, Sri Lanka University, and the Sri Lanka government agencies. Next one. And we also have a good observation joint effort. And we publish a very important paper in international journals. Next one. And the last one, I would like to show the education effort. Since 2016, we have so many training students from Sri Lanka. I was informed that now it's marine and climate sciences. We already have more than 100 students got a master and PhD degree in China. Next one. Yeah, let's boasting much more conception of initiative and role and with Sri Lanka and China. This is a very brief introduction. Then let me show my former lecture today. I would like try to deliver very fast. Fast study. You can hear you and you can watch my PPT, right? Can you see me? Can you see my PPT slides? Okay. So this is a moisture flux impact of DITWAH cyclone on rainfall and the flood disaster in Sri Lanka. Next one. This is a cyclone introduction. This made landfall November 28th before move back over Bay of Bengal, triggered very severe flooding in entire Sri Lanka country. I think it's reached the record since the early early 2000s. So this study would like to answer why so strong or so severe flooding happened. And I was told by a news reporter in Sri Lanka, 50,000 homes was destroyed. And so many people is impacted, more than 1 million people. And I was told about 400 reported missing and dead. It's a really disaster in the Sri Lanka. Next one. During the cyclone, meteorology and observation was data obtained by China Sri Lanka joint stations. Which one is located Colombo? It's in the port city, and also one is in the Hambantota. And in Colombo, the important the observation got more than the wind speed of more than 17 meters per second. So this is a very, very strong wind. And notable disease of atmospheric pressure was recorded. Later I will show you the detailed time series. And Hambantota wind speed also very strong. So even a little bit weaker, but still destroy lots of building and lots of forest. Next one. This is a record of Colombo station, wind speed and the direction. As you see in the box, red box, I show the sensor got a very, very strong wind speed. So, the humidity and the air pressure in Colombo, in the port city, in China, yeah, those port city stations show you the very strong humidity accumulated and the air pressure goes down. Very low pressure. Next one. And then can you hear me? Hello?
Yes, Professor, we can hear you clearly.
Okay. And in Hambantota, yeah, also we got a very strong wind speed. That's the reason why we installed the Nigambo incorporation of Sri Lanka Ocean University. Anusha and Dr. Anusha helped us to install the sensor of the branch of Ocean University in Nigambo. Next one. Okay, let me show the our method in this quick analysis. We using the moisture flux definition is equation 1. This is moisture flux, means the two-dimension horizontal moisture flux goes to north or goes to east by positive value. And we also using its conversion of moisture flux because the rainfall is directly related to the conversion of moisture flux. Other land here related with moisture flux is a conversion value. Data come from ERF 550 and GHRSSC to show the ocean temperature impact. Next one. This is a check of the lifetime of this strong cyclone. Started with November 26th, and then hit Hambantota quickly 2 days later, and passing by slowly a little bit along the eastern part of Sri Lanka, and then back to the Bay of Bengal. But the disaster is caused mainly because the tropical cyclone stopped in the east of India coast, and even go back to the source. So then this go back and the return time. It's bring lots of moisture and impact of the rainfall. Next one. I will show you why ocean is important. This is the seas of temperature and superimposed with the wind field during the tropical cyclone over east of Albacete and Tojo Bay of Bengal. So we start with the temperature with November 25. This is a very initial state of tropical deep, tropical low, and then goes to 2 days later, it's like a DD, deep pressure, and then formed like a 29, it's a strong, 28, it's a tropical cyclone, strong tropical cyclone, and it goes to northward, and in November 13, it is like a stations, steady state, stopped at the north of the Sri Lanka. Next one. The temperature always very high. See, let me zoom into the temperature around the Sri Lanka. As you know, when the northeast wind started, sometimes the temperature will goes down. But as you see, the initial time when the tropical cyclone, the temperature is still very high. That means the local moisture supply still very important, very strong. So that is, kind of an additional moisture impact to this tropical cyclone, and eventually bring the very record rainfall over the entire Sri Lanka island. Next one. And let me show you the evaporation. The evaporation between from the ocean is very strong. I show you the value. See, you can color bar. In the November 25 and to the November 13, all the moisture can significantly evaporate from the ocean and accumulated by the atmosphere, inside of atmosphere. When the convergent time happened, all those moisture will goes to run off, deliver very strong flooding over the island. Next one. And this is also the evaporation variation of the Sri Lanka. We can see the variation is time increase. So we can say over the ocean, those evaporation from ocean is give lots of vertical moisture flux. So all those vertical goes to from the ocean to the atmosphere. Next one. And we did a small calculation. We use the vertical integrated moisture flux to show the initial time. Those is vertical integrated, not just as a surface. We goes to from the surface to a little bit boundary. So this is include horizontal flux. So this like is a horizontal plus vertical one. Next year. Yeah, and how about the EIA moisture and the moisture flux and then moisture conversion? as I said, moisture and moisture flux conversion is very important. The vector is moisture flux, and the color bar is moisture flux conversion. The up planar show the EIA, the realized data, and the low planar we use a Wolf model with a research model we call Wolf, with a research forecast model. Those two planar, you can see our reanalysis data maybe have overestimated of the moisture conversion. But my model with Wolf low planar show much more moisture conversion, flux conversion over the south part of Sri Lanka. As you can see, as you see the low planar, the color of the southern part of Sri Lanka, those rainfall is come from. The rainfall formed at the beginning. It's at the beginning is over there. Next one. And then we show the model result of moisture flux and the moisture flux converging. A little bit wider window, not just Sri Lanka. We show surrounding Sri Lanka the favorite condition. I mean, inside toward the island, the moisture flux come over from the Bay of Bengal and the tropical equatorial Indian Ocean and Arab Sea. And those moisture flux will converted over the Sri Lanka. So that is from the 26 to 16, 25 to 16, to 13, all those moisture, just previous over the, above the Sri Lanka island, all surrounded. So this is the eventual brought the rainfall. Next one. And we see the rainfall. Again, the up planar is the rainfall of the EIA data, EIA reanalysis. EIA means European Center Reanalysis data set. And later, a low planar is our Wolf model result. That EIA is like a co-resolving. But the fine resolving model, local model, show the rainfall more exact rainfall. It's very similar of the Department of Meteorology in Sri Lanka. The newspapers show such a pattern is not good catched by the EIA 40, the EIA reanalysis, but we reproduce very good of Wolf data, Wolf model. Next one. And this is a runoff. When rain come down to the surface to the land, eventually will goes to the ocean by runoff. So maybe at the beginning, as I said, it's not it. But when the tropical cyclone stop in the north of Sri Lanka, east coast of India, east of India coast, then the particular in the Colombo, lower and left, you will see in the Great Colombo area, the rainfall. This is why the river of Kalania River have a so strong flooding. Okay, next one. And then let me show the total rainfall and the runoff. This is I showed the overview, the rainfall and the model rainfall, the runoff, and the low data is from UNDP. This is we show the those flooding happened so strong, but it's not so strong in south. Maybe because it's far away from the location of tropical cyclone, because the location tropical cyclone is also in the middle of Bay of Bengal. Next one. This is impact of agriculture. The Sri Lanka reported so many data to FAO, Food Agriculture Organization of UN, and we got this data from Department of Agriculture of Sri Lanka. So those for the paddy, vegetables or field crops from the middle and to the north. The exception is Luhuna and Jaffna Peninsula. All other area is strongly, such as paddy, vegetables, and other field crops is strong impact. Most is like is destroyed by the rainfall and the flooding. Next one. So the home take-home message. In this study, we use EIA-40 and our local WOF model. This model also we are installed in the university, Sri Lanka University of Sri Lanka Ocean University. We are training Dr. Anusha and Priyasa to use this model. And our major conclusion found that the very strong high temperature mini warm pool over the Sri Lanka waters and provide a very strong vertical evaporation. And also the high radius cyclone, because of cyclone and the sudden stop, a slow move and sudden stop in the east coast of India. So this stop is very dangerous. And the high cyclone wind increase evaporation as show the mode output. And this results in high rainfall through Sri Lanka. And in the end of top cyclone, the rainfall happened over the Greater Colombo area. And high rainfall yield flooding. And this flooding, it's high recorded. It's a consequence of flooding region. And the high rainfall of Sri Lanka also, superimposes the northeast winter monsoon. Those in winter monsoon brought lots of moisture from north part of Sri Lanka. Then south part of local evaporation and from north part of moisture have a converging story over the Sri Lanka. This is a take-home message. Next one. I think I was because I studied the tropical cyclone over the Bay of Bengal so many years ago. This is recent published my student paper, Joe, in Fudan University. As we see, Bay of Bengal cyclone, it's very hard to forecast, and we need a joint, effort to collect the data and increase our model scheme and even the data simulation scheme, then to more accurate forecast the tropical cyclone impact of the Sri Lanka. This is our target for next cooperation with between Sun Yat-sen University in China and Sri Lanka Ocean University in the later. Thank you. I may next year. I stop here for question and comment.
Yeah, thank you very much, Professor, for your insightful and informative talks on the recent disaster of Sri Lanka. Your expertise and comprehensive explanation help us better understand these causes, impacts, and the broad implications of this event. Before we move into the Q&A session, we would like to take a group photograph at this moment, and I kindly request all participants to please switch on your cameras. Thank you.
Anyone have questions?
Nika. Professor, could you please press the stop sharing?
去掉了。网银去不要共享了，不要共享，直接共享。OK。Yeah, any question and comment, welcome to post in the chat box. I think Anusha, Professor Dr. Priyasa, there's someone try to say something, right? CEO, but the mic is not open.
Yeah, Professor, we will ask the question. We have some questions to us.
I think we need to publish this paper as soon as possible. Priyasa, I will visit Colombo.
Professor, yeah, Professor, I am Priyanka here. Professor, can you hear me?
I can hear you.
This is a very good presentation. We have gone through the presentation, and I have noticed that you study about the sea surface temperature. Did you compare the sea surface temperature together with the sea surface height? Because sea surface height should be changed according to the temperature changes. So it may also some indication for the DITWAH cyclone. Did you check that with the sea surface height?
Can you repeat? Anusha, can you repeat? This is from Priyasa.
Yeah.
What the Priyasa?
No, I am asking about, did you check your sea surface temperature together with sea surface height? Did you compare those?
Okay, I have a question. Okay, during the La Nina. Okay. Yeah, this is a very good question. Because what we big analysis, we did not have enough time to study the IOD impact. Maybe we need to use the regional cup model. Regional cup model to show the impact of Sri Lanka rainfall. 我还是第一次在这里看到你哦，啊。
Professor, we have received some questions. The first one.
Already answered first. You already answered.
Yeah, the first question, dear Professor, thank you for the wonderful presentation. I have a question. Our research suggests cyclone DITWAH occurred during concurrent La Nina conditions in the equatorial Pacific and a negative Indian Ocean dipole in Indian Ocean, which can modulate regional moisture availability and low-level monsoon flow. Did your WRF experiments control for La Nina and negative IOD? And can you explain their impacts on DITWAH circulation and rainfall? This is one question we received.
I would like to take the second question. Expect more cyclone in future.
Yeah,
Because,
Can we expect?
the second question, can we expect more cyclone in future due to rising SST in Bay of Bengal, especially during post-monsoon period? Then how we can mitigate it?
yeah, it is very difficult to forecast because the scenario of global warming, it's so diversity. So, but if the forecast of global warming is fixed, we may say more strong cyclone happened in over Bengal, but maybe less cap cyclone. Cap cyclone is strong, much stronger than now, but less. This is the conclusion of a previous study. I agree with that conclusion because more SST provided the moisture. But the more SST will kill. I'm sorry. The strong tropical cyclone will absorb the more heat from the ocean, so the number of tropical cyclone will become less if the global warming happened. And how to mitigate it? This is a very good suggestion for us. We needed to forecast the tropical cyclone, both the intensity and the track is more accurate, because this information is very important for the emerging agency, emerging response agency, reaction agency. And the second one, we need to have a more hydraulic construction, because when the flooding happened, such as the river of Kalania, if we have some local reservoir and more efficient civil engineering in both sides of Kalania River, then the flooding will destroy less construction and the house, and the less destroy can be forecast. So mitigation is very, very important. If you read the IPCC volumes from those years, you can see the mitigation is a very, very important task for the science and the government. I strongly suggest University of Sri Lanka, Ocean University of Sri Lanka, to include the meteorology or climate sciences into the ocean sciences. This is the same story in China. We, Science University, my department, my School of Marine Sciences, very strong climate dynamic research groups. I hope Vice Chancellor of Sri Lanka Ocean University can hire a couple of meteorologists and enhance our cooperation between China and Sri Lanka about the climate, about the ocean sciences. Thank you very much.
Professor, can I make some comments regarding your suggestions? Actually, we have in our curriculum, we already have several modules regarding the meteorology as well as some atmospheric science.
Could you repeat a little bit because of noise?
Professor, in our Ocean University, the BSc, we are offering the BSc Honours in Oceanography degree. Under our curriculum, we already included the Introduction to Atmospheric Science and the Meteorology and Ocean Forecasting modules to develop the future meteorologist, actually.
Yeah, we pay very close attention to the education, joint effort of education system. Actually, this year we would like Yasa to visit us.
And Professor, also we have another question. Are there any changes in the sea level due to DITWAH cyclone during this period? Did you observe any changes, sea level changes around Sri Lanka due to DITWAH?
Yeah, this is also the international community already answered the question in the long run how the sea level change with Sri Lanka coastal stations. Because Sri Lanka did not have a long record data, but with the prox data, such as Dr. Nalaka from Ruhuna University before, he back to Sri Lanka, USA again. According to his analysis, the sea level in the south part of Sri Lanka, from the Colombo to Hambantota, the sea level rise will be very in agree with the global tropical sea in week in North part, like Jaffna Peninsula. This is the conclusion for sea level rise. Thank you.
Thank you, Professor.
Professor, we have Professor. I am Priyant here. We have one more question. Actually, we can get the predicted path of the DITWAH and the actual path of the DITWAH, but there are some slight changes between the actual path and the predicted one. What would be the reason for that? What do you suggest?
Yes, sir. You say again? I did not get the exactly. Dr. Priyasa.
Yes.
Please, would you please post folks?
Yeah. Professor Wang, we want to know that there is we have observed that there is a slightly changes regarding the predicted path and the actual path of DITWAH cyclone. What is the reason for that?
The sudden stop. Is it a story about a sudden stop of the tropical cyclone? The sudden storm mainly because the northwest monsoon, boost. Because it's already before tropical cyclone. Well, Bengal already in the winter monsoon season. But in the tropical cyclone, the winter monsoon is strong. And when it goes to north, the winter monsoon So then the sudden stop of the tropical cyclone happened when the tropical cyclone located in the north of Sri Lanka.
Okay, thank you, Professor. We got the point. Are there any questions from the audience?
Hi, Professor. Can you hear me?
Yes.
Hi, Professor. I'm Arandhani from Singapore, NTU University. I think Professor know me, must be. So I have a quick question just to clarify about the TC-induced rainfall. So you have mentioned that DITWAH TC contributed by 78% to the total rainfall, but the any monsoon has contributed by 28%. So, but I didn't see any figures related to that. So I think you have discussed about the TC, not only the TC induced rainfall, but also all the accumulated rainfall during the TC DITWAH. So am I correct, Professor? Is this?
Yeah, I agree with you, but the exact story what I show is complex because the time evolution and the spatial cover. When you look at the zoom out picture, the larger picture, not just focus on Sri Lanka coastal. If you include the Bay of Bengal, entire Bay of Bengal, and the chalk in the ocean, there's something information like La Nina situation and IOD condition. It's really become important. So we need to, as I said, we need to carry regional couple model to test, of course, with a larger scale, the entire chalk in the ocean, North chalk in the ocean. So to even, as I said in the last picture, the east part of Bay of Bengal, such as some strong, larger mountain, they also will change a little bit ALC land cooperation interaction process. So it's not easy to reach a conclusion why this strong tropical cyclone happened to put so many rainfall over the Sri Lanka, particularly around the area of river Kalania.
Okay.
Ghana.
Yeah. Thank you. Okay, thank you. Thank you, Professor. Thank you for the clarification. Thank you.
See you next time in Singapore.
Yeah. Professor, we have received one.
Sorry, Professor, I'm postdoc at NTU. If you remember, I completed my master's in CSIO. And now I'm a postdoc. I completed my PhD and I'm working as a PhD in postdoc in NTU. Yeah.
Let me take the cut question. Why didn't the low pressure dissipate on the land as we have experienced in the previous low?
I think it is related with the topography of Sri Lanka. It is comparatively small landmass, and especially because of the highland in Sri Lanka, I guess it is deviated toward the eastern part. I'm also working on the DITWAH cyclone right now, but in my results I found out that TC-induced rainfall contributed less amount compared to the non-TC induced rainfall over Sri Lanka. But I need to conduct more experiment to confirm the results. I just begin the research. It's just a beginning. Yeah. But I guess it is mainly because of the topography and small. It is ended from the eastern part of Sri Lanka. After become a tropical cyclone, after past the 34 knots. Before that, it is low pressure, just a deep low pressure system. But when it is entered Sri Lanka, it is pressure maximum induced speed past the 34 knots. So we need to conduct, as my suggestion, we need to conduct more analysis focusing on the topography of Sri Lanka.
I read the number 3 question. Yeah, this I think the major problem is island is so small, but the tropical cyclone this time is very wide, very long distance from eastern part to west part, and from north part to south part. I mean, the size of tropical cyclone is larger than before. So maybe this is the reason why the low pressure did not stop.
Do you have any more questions from the audience?
Why
If you don't have any more questions, we can conclude today's webinar. I would like to take this opportunity to sincerely thank once again for our resource person, Professor Dongxiao WANG, for sharing his valuable insight. And also we would like to express our gratitude to all participants for their active engagement and participation. Thank you all and have a great evening. Thank you.
Thank you again. See you soon in Sri Lanka.
Yes, Professor. See you soon. Thank you.
好，网页可以关掉了，谢谢。